Yeah. So I think 10 minutes,
you're,
7 minutes.
yeah, something like that. You're little early, so I want to chat with you for some time because fraud detection is some issue that's not so new to us, like image recognition or other aspects. The finance and the insurance industries in Turkey are very much interested in this. So before your presentation, or will you have a presentation?
I do, yeah.
Yeah, okay. Before that, we can have some chat about this issue as people from different age groups are starting to use the online services. And also behaviors are changing. It's not a custom behavior. So how is fraud detection changing? I want to talk a little about this. Because things become extraordinary.
Yes, right. So I think what's really fascinating, so one of the things that's really interesting about what's happened, so particularly in COVID, right? Like actually, in the UK, in the US, things like that, like, lockdown, everyone is kind of, they're not buying at their normal shops. Everything is buying online, all of these kinds of things. But what's really interesting is that, what people need and what they kind of buy is very similar, right? So actually, maybe I was buying from Tesco in the shop, and now I'm buying from Tesco.com. So it's a very similar merchant ID, very similar merchant name, things like that. And so I think what's really helpful is that, if you have a sense for what people are doing, right, online, then, that really, that really helps. The other thing as well is that actually, thankfully, fraud is very rare. So like so much of behavior is genuine, right? So you actually have the ability to learn what people are doing in terms of genuine behavior. And what's interesting is that all of these things that really took off in terms of online services or things like that, they all start usually quite small. So you have some history over time. So it's a small group of people that, use these kinds of things. Or so one of the things that's interesting is that, like, the UK is now having some problems with like Bitcoin scams, right? So people are investing in Bitcoin, things like that. But you always know that they're risky because they were always risky, right? So actually, at the moment, yes, Bitcoin is in the media. Everyone wants to buy that stuff, things like that. But even when it was not in the media, people still complained that, hey, I bought this, I lost money. These people didn't deliver what they wanted. It got stolen, things like that. So actually, it's very rarely the case that something is like entirely brand new and explodes into the scene. So if you have, enough ability to kind of track the history of a particular merchant or track the history of particular cards or whatever it is, you often have enough data to make good decisions going forward.
Wonderful. And what we saw in Turkey was actually during the pandemic, especially in the first months, we always read articles like this. So many people used their credit card for the first time on e-commerce, and e-commerce volume jumped up like this. And those people are new people. So it's very hard to understand their behavior. They may make mistakes. They may wrongly put the wrong passcodes and things like that. So there are such problems, and those anomalies are hard to discover. That's what we faced in Turkey. So I want to get your opinion on that.
So I think, in particular, like I said, the transition between online and offline, or offline to online. I think, there are some situations where, where people are using first time. Oh, well, I need to go get my phone. There's SMS, there's passcode, things like that. So those are one layer in the detection, right? So basically, again, like any security system, any fraud detection system, is defense in depth, right? Okay, well, you make sure that you don't get clearly fake people. You don't give them clearly fake credit cards. you have a credit limit, then you have like, a chip, or, for online transaction, you have a CVV code and like address verification online. Like there's a whole, and so actually when it comes to our system, like, to our like transaction fraud detection system, a lot of these checks have kind of passed, right? So I think, and, when you have like these security checks, they're very noisy. Because actually why you fail, or well, maybe you lost your phone, or like actually your phone is somewhere else and you didn't enter the code in the right time, things like that. And so for us, what we're able to do is to weight the fact that, just because someone has, like not entered the SMS at the right time, doesn't mean that like actually they're guaranteed to be frauds, right? So actually we have the ability to kind of say, oh, okay, well, if they haven't entered the SMS at the right time, the chances that the next transaction is fraud is maybe 3% higher, 5% higher, but it's not guaranteed fraud, right? So we're able to learn the correlations between like what they've just done and what impact that has on the next transaction.
Okay.
So, and actually, I'm really curious, right? Because I am really curious about like what issues that you faced, right? Like as you kind of, go through like, a lot of change in people's behavior online to offline, things like that. So what else did you see?
Well, actually, we saw, it was like a kindergarten, actually. Many old people trying to use those cyber systems. And just 1 year before, we were talking about the teenagers and saying that they were always on the mobile phone doing everything. They're not social and things like that.
Yeah.
And everybody became like that, and they were experienced. So we faced many problems related to this, but actually it didn't come to fraud. What I wanted to see is, and there are not much statistics about it, the misunderstanding of these behaviors and mistaken as fraud was an important issue here, because it was like the DDoS attacks. Actually, they just lacked your system. Yeah. So that was one point. Maybe we can talk about behavioral AI. But first, let's not miss what you'll be presenting.
Yeah.
So and then we'll go on. Okay. So now I'd like to leave the stage to you for your presentation.
Okay. Very kind. Are there other people that we expect to attend, or is it just us?
Well, actually, we're broadcasting this, and you cannot see them, but they're listening to you.
Great. Okay. So let's begin. So
yes,
let me.
Actually, this was an open conversation.
Oh yeah,
they were watching us. Maybe you just saw two of us on the screen, but we're
awesome, right?
We're
live. Yeah. I really like the fact that we can have open conversations, right? So like this is a good thing. So let me just see. So I can share my screen. Can you see that? It should say Turkey Week.
Yes, and it's full screen, so the stage is yours. You can go on.
Okay, brilliant. So, so thank you for giving me the opportunity to talk. It's always a huge amount of fun coming out. So what I want to talk about is 4 things. So Batul gave me like a really good briefing. So I kind of want to talk about Featurespace because I know that we're not famous in Turkey. I want to talk about card fraud detection systems and how you might go about doing that with classical machine learning. I want to talk a little bit about like deep learning and those techniques. And then one of the questions that I had was, what is the AI ecosystem for you, right? Like, how does this ecosystem work? And I have a slide on that. So, I have a lot to get through, so I'm going to get started. So Featurespace is a British software company. So, founded in 2008 out of Cambridge University by one of my professors. So this guy called Professor Bill Fitzgerald. And we invented what we call adaptive behavioral analytics, right? So the ability to follow behaviors for individuals and, use those to make predictions customers include major banks, payment providers, things like that. We're now a global company. We have offices in Singapore, London, Cambridge, and Atlanta. And, we operate at real scale, right? So we kind of process about 50 billion events a year. And our solutions have won multiple awards, right? So I think in the UK, one of the biggest awards is the Cards and Payments Awards, and we've won that twice. One for the foresight score that I'll talk about, and one for scam detection. So who are our customers? So, some of the biggest banks and payments providers in the world. So if we look at, WorldPay, one of the biggest merchant acquirers in the world, TSYS, one of the biggest credit card processors in the world and the biggest in the US, I think. IATA, airline tickets, NatWest, a big high street bank, HSBC, global bank, Danske Bank. I mean, actually here are MUFG, one of the largest banks in the world. So, and in particular, one of the things that I want to talk about here is TSYS is the largest credit card processor in the US and one of the largest globally. And so we jointly developed a product called the Foresight Score. And a large national bank on one of their commercial card portfolios achieved absolutely incredible results, 75% fraud prevention at a very small false positive rate. So for every one transaction stopped, one fraud transaction stopped, they only interrupted 5 genuine transactions. So great. So what does the classical machine learning approach to card fraud detection look like? So before I talk about classical machine learning, I might actually talk about, the historic rules-driven systems. And actually, they lead generally to very high false positives, right? So, and I've heard so many stories talking to customers, or when I tell people at dinner or when I go out, I ask them, they ask me, hey, what do you do? I say, I produce fraud detection systems. And everyone has a story of, hey, why I got this transaction that was blocked, it was genuine. I've always shopped there, their systems must not be very good. Is your system any better? And then if you're within a bank, your analyst will often tell you, hey, this account always alerts, even though this is the 4th or 5th time that this exact pattern of activity I have said is not risky. And the situations occur because existing systems do not often take into account historic behavior. So they will say, if the transaction is over $4,000, or if they have spent more than 5 times at the same place, then decline. And also they don't take into account feedback from the analysts, right? So what is genuine, what is fraud? Because actually, so situations like this where it's exactly the same transaction amount, exactly to the same person, but we're not learning the fact that this behavior is genuine, probably because this is a large transaction amount. So card fraud, of course, people look at card fraud and talk about, the fraud losses, right? The amount of dollars lost to fraud. But actually, that's just the tip of the iceberg, right? So for every transaction that is fraud that you catch, very often you're interrupting a lot of genuine transactions. So the false positives lead to very big operational costs and reduced interchange revenue. So interchange revenue is when someone spends money on a card, the issuing bank gets a percentage of revenue back. And then the last thing is poor customer experience, right? So if someone is constantly interrupted or have a bad experience with fraud controls, then they lead to lower loyalty, they might use a different credit card or things like that. So just the losses themselves are the tip of the iceberg. And when you're kind of building fraud detection systems, you need to worry about the false positives and the customer friction too. Okay, so great. So what do card transaction looks like? And actually any transaction log in general records, really simply just 3 things, right? So it's who paid whom, how much money, and at what time. And so, here, on the subsequent pages, you're going to see, this is the customer, this is the transaction time, this is the amount, and this is the merchant. And, with transaction data, it's always tricky, right? Because, if someone is using that card abroad, then actually, is it the time in the local, or is it time at your bank's systems? There's almost always other useful information available. So the merchant city, the merchant location, And usually there's richer detail available, right? So the merchant address, city, zip code, things like that. And then the last thing that I have omitted here for clarity is the security checks that are recorded, right? So did you do 3D secure? Did you send them an SMS? Like, a bunch of things like that. Okay, so without further ado, Karim, I think because it's just the two of us, you might need to answer some questions for me. So let's see if we can. Let's see if we can go. So what I want to do is to kind of give people the experience of what it is like to build features or to kind of look for something that is fraud. So let's see. So here is an account history. So here's account one. This is all transactions for one day. And of these, there are some transactions that are fraud and some transactions that are genuine. So which of the transactions on this page do you think are frauds?
Let's see the time. Well, the Ankara transactions look false for me.
Yes. Why? Correct.
Because mostly you don't go there so often, and well, the time that you purchased the last thing in Istanbul and the time in Ankara is 22 minutes, and it's impossible to go there in that period if you don't have a plane.
Oh, or teleportation machine. Even in a plane, it will take you that long, right?
Yeah, I think so. And why would you get two times the money from the cash machine?
Exactly, right? So again, like all of those are wonderful, wonderful examples. And so I think the key thing here is what's really nice is that automatically when we're trying to spot fraud, humans think in terms of behaviors, right? So actually what Karim has done is kind of looked at the entire history to say, here's someone who looks like they live in Istanbul, they've spent a lot of money there. And actually this behavior of spending money or withdrawing cash in Ankara is unusual. And so I think a lot of what our data scientists end up doing is kind of understanding the domain, understanding the behaviors of what's genuine and what's not, but also being able to encode these behaviors in terms of numbers, right? So one of the numbers might be, what is the speed between my previous transaction and my next transaction? So here, the speed is something crazy. It's something like 1,200 kilometers per hour, right? It's really fast. And so actually that stands out as enormously high. And the reason you might want to calculate the speed is because then if someone was in Istanbul, or someone was in Ankara and then they spend money in Istanbul, the same technique works. Or it might be that they're in Izmir and it's in Istanbul or whatever it is. But actually the distance, the cities themselves don't matter, because you could very easily write a rule to say, for this person, if they spend money in Ankara, that's false, that's fraud. But actually a much more robust way, a much more generalizable way to compute this number is to say, what's the speed between these two locations? And then actually, if that number is very high, then that's fraud. Great. So that's one example. So next example. So here is again, very similar. So this is a different account, very similar day. What are the transactions that we would be suspicious of?
From Steam.com.
Yeah,
the one from Steam.com. And the amount is very high.
Amount is very high?
Yeah.
And actually, is there anything else that kind of makes you suspicious about that Steam?
Yeah, the interval between the transactions.
Exactly, right? So actually, I would be suspicious of both of them because there is a common pattern where if someone steals your credit card details, they first try it for a small amount to check whether it's working and on a small amount. And then the interval between the transactions is very small, and then they're trying to get as much money as they can out of your card because they now know that it's working. So again, like a different way.
And there's not another internet transaction on the page.
Correct, right? So this is the first time that this person is spending money on the internet, right? So again, there is something there that's interesting. So if this had stopped just at 1301, it's a small amount, you might let that go. But actually, the fact that you see this pattern of big transactions in the same, in very close proximity, like that might be suspicious. So one of the numbers that we might use to encode the fact that, this might be a test followed by like a high value is, so I have often seen rule systems where they have, like lists of test amounts, right? It's like 79, 89, 99, 101, $1, all of these kind of things. But actually a slightly more generalizable way to compute exactly this kind of pattern is to look at by how much is the payment increasing per minute. So here the payment is increasing from the previous one to this one. It's increased by 320 in 1 minute. So that's an unusually high increase in payments. Whereas if you kind of look here, I mean, it's actually decreased. Here it's increased $2 in so there's 3 minutes difference and there's $6 difference. So it's $2 a minute that's increased. So actually this really stands out as unusually high because the payment dollars have increased a lot in a very short space of time. So whether it's 1 minute or 2 minutes, whether that's $99 and $300 or $299, if you look at the increase in payment amounts per minute, then it's very easy to find anomalously high increases, right? So with classical machine learning, you kind of do a lot of this stuff and you pick up a lot of tricks, right? Where you say, hey, here are the variables that I need to find, things like that. And so what is really important here is that thinking about behaviors is a very powerful and natural way for us to spot genuine and fraud anyway. And so what Featurespace's platform does is it provides very powerful tools to be able to follow any entity's behavior over time. So we've talked about cardholder behavior, but we can do it for merchants, we can do it for merchant locations, we can do it for merchant categories, we can do it for a whole bunch of things. And so we can express all of these behaviors in terms of numbers. So we can say how far it was from the previous, how many in the last 24 hours. Then we can look at merchants, right? What's the standard deviation? What's the percentage above the merchant average and so on? And then we can learn some weights on each of these numbers to produce a score. So that's how classical behavioral machine learning works. How does this work in real life? So this is a UK credit card issuer. And by applying these techniques, we were able to reduce their false positives by 70% at the same time as reducing their fraud losses by 40%. So again, this client is very sensitive about numbers, but here is another French international tier 1 bank, right? So their fraud value detected from their existing system was about 30 million, and they lost about 56 million in fraud. And by applying our techniques in a proof of concept, we were able to reduce their fraud losses by 13 million, so from 56 million euros to 43 million euros, right? So actually, that is a substantial amount of money per year that we were able to save them, plus the false positive ratio. So they were able to operate at much better detection, much better fraud detection rate. So they went from 30 to 50%, but also simultaneously, a reduced false positive rate, right? So that's actually pretty good. And so, of course, if you have a good system like this, then it's easy to say, yes, I'm great. And, let's try and sell more of these. But at Featurespace, we really want to push the boundaries. So we asked ourselves, okay, well, this is really good. This is market leading. How do we make this even better? So great, right? So what we looked at is deep learning. So deep learning has really started to grab attention in 2012, particularly in image and text and things like that. And so the problem with deep learning for credit cards is that customer transactions are sequences. And all of the techniques available for sequences, like recurrent neural nets, LSTMs, things like that, they all assume that the data is evenly spaced. And so Featurespace's innovation and patent is dealing with irregularly spaced data. And how did we do this? We built an architecture that's very similar to the process that we just went through. We said the first step was to have the time gap as an input to the neural net. And the second step was to dedicate specific sections in this architecture to track behavior over days and weeks and months, because this is how humans typically change their behavior. So what I'm not going to do is change, I'm not going to, take away how many experiments we needed to do, but we ended up with architectures that finally outperformed our hand engineered models. And so this is, well, okay, so all of that is great, but let's talk about what the results were. So this is,
and we have to complete in 2 or 3 minutes.
Yeah, 3 minutes. That's perfect, okay. Right? So what were the results? So this is our own adaptive classical machine learning technique, where at 5-to-1 we caught 26% of the fraud. And so, well, what did the deep behavioral networks do? They caught 10% more fraud. We went from 26% to 36% of frauds, but actually the fraud detection rate, so, you can see that 10% changes work out to millions of euros a year. And then what you could also do is you could say, well, actually, I'm happy catching 26%, but I want to annoy fewer customers. So you can go from 5-to-1 false positives to 3-to-1 false positives, right? So actually, that's, again, like a huge reduction in the number of customers you annoy. And so the last thing that I kind of want to talk about is our AI ecosystem. And Featurespace is lucky in that Cambridge University is on our doorstep, right? So we regularly collaborate with academia. We also regularly collaborate with people in the industry, with fraud analysts, data scientists within our customers. And the last way in which we kind of contribute to the ecosystem is we contribute to open source, both databases and the open source software ecosystem. So we kind of publish and upstream patches for components we use, but we also pay other companies to fast track features in open source software that is then released for community benefit. Really, so that's the last slide that I had. And if I have any time for questions, then I'd be happy to take them.
Actually, we had a lot of conversation, and we'll connect to our friend in Germany. So we have to move fast because the Germans are very timely. Yeah. So thank you for that, for the explanations.